Welding is a process that joins metal by melting or hammering the workpieces until they are united together. There's three general types of welding. There's gas welding, electric arc welding, and electric resistance welding. In this video, we will discuss gas welding utilizing the acetylene torch.
Hello, I'm Jesse. I'm a student here at Savannah Tech. I'm going to walk you through on how to set up your welding torch using your acetylene bottles and your oxygen bottles. First, you would start with the acetylene bottle and you would turn it a quarter to a half turn, which then you would see your gauges right here, which is showing your PSI within your tank, and then you have to your right here, you have your PSI, which is set at 5, which is the proper amount for the acetylene torch. And then you would come to your oxygen bottle, and then you can just turn that one open, and again you have your regulator for your tank, and then you have your regulator for your hose for the oxygen, which we would be set at roughly 10 psi. Alright, now I'm going to show you how to ignite the torch. First, we're going to start with the acetylene valve. We're just going to crack it open to hair, and then you're going to take your igniting tool and you're going to come close to the tip here and spark it.
The regulator working pressure should be set according to the manufacturer's recommendation for the tip size that is being used to weld or cut. The regulator working pressure for oxygen is 10 psi. The regulating working pressure for acetylene is 5 psi. With the working pressure set, welding or cutting operation can be initiated.
Hello, I'm Kyle. I'm a student here at Savannah Tech. And today I'm going to be telling you about the different flames used in welding. There's 3 different types of flames that you'll be using: a neutral flame, a carbonizing flame, and an oxidizing flame. And the amount of oxygen you use determines the flame color and the pattern.
I'm Tim. I'm with Savannah Technical College, and I'm going to go over how to come from your basic, from striking off with your acetylene flame here, and bring it into a neutral flame. I'm going to go ahead and start by backing that soot off a little bit. Get a good solid flame. You're going to slowly work in your oxygen until come through the carbonizing flame until that center cone comes to about there and it's stable. And you're going to back off on that acetylene to soften that flame out and get rid of the roar. At this point, you have a solid neutral flame. The major characteristics is this cone here. Bright, short, and stable. As you can see right here. This flame is generally going to be used, the base flame, for everything you do with any kind of cutting or welding. When you're using a cutting torch, this will be the flame you start with to preheat your metal. When you're welding, this is going to be the flame you're going to use because this is not going to change any of the metallurgic properties of the metal that you will be welding or cutting on.
The neutral flame burns at approximately 5,850 degrees Fahrenheit at the tip of the inner luminous cone and is produced by a balanced mixture of acetylene and oxygen. The neutral flame is used for most welding because it does not alter the composition of the base metal. When using the neutral flame on steel, the molten metal puddle is quiet and clear, and the metal flows to give a thoroughly fused weld without burning or sparking.
I'm Elijah. I'm a student here at Savannah Tech College, and I'm going to show you how to get from a neutral flame to a carbonizing flame. So the carbonizing flame is actually whenever you have more acetylene than oxygen. So there's 2 ways to achieve that. You could add acetylene or take away oxygen. And I'm going to do the second. We're just going to dial back the oxygen just a little bit here. And you see that as I do that, the inner cone is going to grow, and we end up with this green, featherish kind of tip there. And that is the characteristics of a carbonizing flame that you're looking for. As it burns just a little bit, not quite as hot as the neutral flame.
The carbonizing flame burns at approximately 5,700 degrees Fahrenheit at the tip of the inner core. It is also referred to as a reducing flame because it tends to reduce the amount of oxygen in the iron oxides. The flame burns with a coarse rushing sound and has a bluish-white inner cone, a white center cone, and a light blue outer cone. The flame is produced by burning more acetylene than oxygen. and can be recognized by the greenish, feathery tip at the end of the cone. The longer the feather, the more acetylene is in the mix. The carbonizing flame is best used for welding high carbon steels, for hard facing, and for welding such non-ferrous alloys as aluminum, nickel, and monel.
Hi, my name is Connor. I'm a Savannah Tech student. I'm going to show you how to get to your oxidizing flame. So we're going to start at the carbonizing flame, which is more acetylene from your neutral. And then now we're going to add our more oxygen than acetylene. And we will get it to this right here.
The oxidizing flame burns at approximately 6,300 degrees Fahrenheit and is produced by burning in excess of oxygen. It takes about 2 parts oxygen to 1 part acetylene to produce this flame. It can be identified by the shorter outer flame and the small white inner cone. To obtain this flame, start with the neutral flame and then open the oxygen valve until the inner cone is about 1/10 of its original length. The oxidizing flame makes a hissing sound, and the inner cone is somewhat pointed and purplish in color at the tip. The cutting torch is an attachment added to the torch handle that allows the cutting of metals. The cutting process is fundamentally the rapid burning or oxidizing of the metal in a localized area. The metal is heated to a bright red color, 1400 degrees Fahrenheit to 1500 degrees Fahrenheit. This is the kindling temperature, using only the preheat bit.
For shutdown procedures, we're going to start by turning off the acetylene to turn off the flame. Then we'll go ahead and shut down the oxygen. I've already done that, so we'll move to the tanks now. So at the tanks, we're going to first turn off the acetylene, and then we're going to open it up. We're going to come back to our torch and bleed it all. So that's all the air bled out of that one. And then we're going to go back. We're going to head to our oxygen. We're going to close it up and open it. My bad. We're going to open it up, and then we're going to open it from here. And that's all. And then we're going to wrap it up, and that's it.